You are surely wondering now, if CO2 is so bad, and we can say CO2 is doing global warming, and global warming is doing so many bad things to us and our health and the planet and the other species, then why did we keep producing so much CO2? Well, kids, it turns out that when we started all this business during the Industrial Revolution and even afterwards, no one thought about the amount of fossil fuel emissions. No one wondered if all that CO2 would bring harmful consequences, not even scientists who knew about greenhouse gases. There were some experiments done already that showed that greenhouse gases can affect the energy balance and trap the outgoing thermal energy and trap more energy, because we already knew about the greenhouse effect and why Venus is so warm and why Mars is so cold compared to the Earth and so on. We just didn't imagine that the way we are burning fossil fuels more and more and more, we were actually producing enormous amount of greenhouse gases, so much so that we would completely change the energy balance and create an imbalance that would continue to add up. As far back as the 1820s, scientists understood that CO2 absorbed heat and helped keep the planet warm. Then in the 1890s, a Swedish scientist named Svante Arrhenius, here he is with his impressive mustache and his nice clothes and bow tie, along with his co-worker Arvid Hogbaum, came up with a new idea. Could all the CO2 that came from the factories be making a difference in the temperature on Earth? Using math, Arrhenius came up with the first climate model, a very simple one, the first study to predict how temperature could rise with greater greenhouse gas emissions. There were some before him as well that had talked about it. Eunice Foote was the first woman, in fact, to talk about it. James Tyndall also had talked about it. Other scientists studying the climate didn't think much of Arrhenius's findings. His model showed that if CO2 increased 2.5 to 3 times the level it was then, around 300 parts per million by volume, temperatures in the Arctic would rise by about 8 to 9 degrees centigrade, or 14.4 to 16.2 degrees Fahrenheit. In other words, he argued that human-made CO2 had a great influence on Earth's heat. Of course, he was right, and in 2012 there was another news article in 1912, there was another news article talking about the impact of CO2. In 1937, Guy Callender made more calculations to show that using measurements that we were increasing CO2 and we were increasing the amount of energy being trapped by these greenhouse gases, mainly CO2. Other scientists questioned whether humans could have such an impact. They thought there is no way we can change the climate of the planet, the weather of the planet, that it is too big, we are too small. The planet had been around for billions of years. Climate had changed before human beings were ever around, before we even existed. They thought that more greenhouse gas emissions might make temperatures go up, but just a bit, not a big deal. In addition, scientists had proven that oceans absorb CO2, so wouldn't most of that extra gas be soaked right up by all that ocean water, which covers 70% of the surface area of the planet? This was the argument. They thought it will just warm by a little bit, and they thought that wouldn't be so bad at all. But in the mid 1950s, a couple of centuries after we began to produce large amounts of CO2, an oceanographer named Roger Revelle ran some experiments. He was at the Scripps Institution of Oceanography in La Jolla, California, which is the western state of the United States. Beautiful beach place, La Jolla. You should go there someday. So he discovered that oceans have a limit to how much CO2 they can continue to take in. They do take in CO2 because CO2 easily dissolves in water, but that doesn't mean they can continue to take up more and more CO2 as you keep producing more and more. And that reaction between the air and the ocean, it has some time that needs to dissolve the CO2 in the water and take it away to deeper depths. Okay, so also they absorb it much more slowly than anyone had imagined. That meant temperatures could rise quickly if the atmosphere begins to accumulate the CO2 we were producing. In turn, rising temperatures could change the delicate balance of Earth's environment, not just energy balance, but everything: temperature, humidity, sea level, glaciers, storms, winds, cyclones, hurricanes, and so on and so forth. It became important to measure accurately CO2 levels in the atmosphere to see if Earth's climate was in danger. And Roger Revelle, we'll see in the next chapter, told his graduate students, Charles David Keeling, who I mentioned before when I talked about CO2 in the previous sections of this course, that he started measuring and put up a lab in Mauna Loa, Hawaii, and we'll see that in the next chapter. In the meantime, let's see how CO2 has increased in the atmosphere since 1880. The green color here, carbon dioxide, which started below 300 ppm in the atmosphere, began to rise, and since about the 1950s it began to accelerate because after World War II economies began to explode, industrial production, export, global economies began to take off, and wealth grew, at least in the developed world, Western world, and you can see we have now crossed 400 ppm, and we are at increasing every year by more and more. We are not just increasing every year, the amount by which we increase from one year to the next has increased itself. And you can see the temperatures, global mean temperatures, are also increasing similarly, and they are also accelerating. And someone may ask, why is the temperature going up and down every year whereas the CO2 is just increasing year after year? Well, CO2 is an inert gas, which means it doesn't easily interact with other things. It dissolves into water like the ocean and the lakes, and the plants take it up, but it stays in the atmosphere for a long time, and it gets mixed because it's inert around the world, and that's why it increases year after year very clearly. Whereas temperature, what happens? If CO2 increases, more thermal energy is trapped like the blanket. That energy goes where? It goes into evaporating the atmosphere, and evaporating from the ocean and into the atmosphere. It goes into melting glaciers, it goes into warming the ocean and expanding the ocean. So the energy is getting taken up by many processes within the Earth system. So ocean may take up heat one year and it may release it back the next year, and this happens in processes called El Nino and La Nina. If you don't know what that is, don't worry about it, but if you're old enough to have heard about it or want to learn about it, you can go on my website, my channel, and find podcasts on El Nino and La Nina. But basically, temperatures averaged over the globe can go up and down every year, but if you look at the climate, then it is warming. How do we do that? Year to year variability, day to day variability is what we called weather. That's not climate. Year to year variability is called interannual variability. Climate, we said, is defined by averaging things over tens of years. So if we average the warming over tens of years, do we see continuous warming? Well, kids, it turns out that indeed we can. Here it is from Climate Central, which is a nice group in the United States, is showing, compared to a baseline, which is not mentioned here, but it is mentioned as anomalies from the 20th century average. So you can think of it as 1901 to 1999 average, and you can see that the temperature anomalies, if you average over a decade, in the 1890s 1880s, 90s, and so on to 1950s, it was cooler than the 20th century in the 19th century. But as we kicked into the 20th century, by the 1940s and 50s, temperatures began to warm up, not only day to day. It cannot happen every day or every year, but it can happen every decade. So you look at the 1970s, it was warmer than the baseline. 1980s, warmer. 1990s, more warming. 2000s, the warming has even jumped, and 2010s were also warmer. So we are definitely warming the climate, which is not year to year or day to day, but decade to decade. This shows that it's not just the CO2 increasing, but all that energy is beginning to appear as global warming when you look at decades of warming. Okay, that should make clear to you that we are seriously affecting the climate, Earth's climate, and everything else. Global warming just means average warming over the globe of the atmosphere, but some people call it global change, which means how are we affecting other species, our health, the vegetation, forests, and so on and so forth. So we'll come back in the next chapter and see how Roger Revelle convinced Charles David Keeling to start measuring CO2, and how now you can go on the web and find what was the CO2 concentration around the world yesterday. They report it immediately on the web, and you can find how we are changing from day to day, year to year, and decade to decade. Okay, we'll do that in the next chapter then.